The National Electrical Code, or NEC, does not mandate splicing wires when connecting multiple receptacles in a feed-through configuration except in the specific instance of multi-wire branch circuits, and even then, only for the neutral conductor. Both the National Electrical Manufacturers Association, or NEMA, and Underwriters Laboratories, or UL, have established comprehensive standards that govern the design, manufacturing, and testing of duplex receptacles. A critical component of these standards includes rigorous temperature rise testing, which is designed to ensure that the receptacles can safely and reliably handle the current flow associated with feed-through connections. The breakaway tau, strategically positioned between the adjacent screws on the receptacle, serves as a safety mechanism. This tau is intentionally designed to break away if the receptacle experiences overheating, effectively disconnecting the circuit and preventing further damage to the device or the surrounding wiring. However, it is important to emphasize that this breakaway tab is not intended to function as a fuse, nor should it be relied upon for overcurrent protection. Its primary role is to mitigate the risks associated with excessive heat buildup within the receptacle. While it is theoretically possible for the breakaway tab to melt under extreme conditions, such as those resulting from a loose connection or an excessive current flow exceeding the receptacle's rated capacity, this is a relatively rare occurrence. The key to preventing such incidents lies in proper installation and meticulous maintenance practices. This includes ensuring that all connections are secure and tight, and that the receptacle is not subjected to overloading beyond its intended capacity. When connecting multiple duplex receptacles in a feed-through configuration, it is generally acceptable and safe to utilize all 4 screws. This method provides a robust and reliable connection, minimizing the risk of loose connections and subsequent overheating. It is crucial to adhere to established electrical codes and best practices during installation to ensure the continued safe and efficient operation of the electrical system. Understanding the design and intended function of the components is imperative for safe electrical work. The purpose of temperature rise testing as part of UL standards is to verify that the receptacle does not exceed safe operating temperatures under normal and fault conditions. The test involves applying a specific current load to the receptacle and monitoring the temperature of various components, including the terminals, the body, and the breakaway tab. If the temperature exceeds the allowable limits, the receptacle fails the test and cannot be listed. The NEC specifies requirements for the installation of electrical equipment to ensure safety. It includes guidelines for wire sizing, overcurrent protection, and grounding. When connecting receptacles in a feed-through configuration, it is essential to select the appropriate wire gauge and overcurrent protection to handle the anticipated load. Overloading a receptacle can lead to excessive heat buildup and potentially melt the breakaway tap or cause a fire. Proper grounding is also crucial to prevent electrical shock hazards. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Multi-wire branch circuits require special attention because they share a common neutral conductor. If the neutral conductor is interrupted, the voltage on the 2 hot legs can become unbalanced, potentially damaging equipment connected to the circuit. The NEC requires that the neutral conductor in a multi-wire branch circuit be pigtailed so that the continuity of the neutral is not interrupted when a receptacle is removed. This requirement is intended to prevent voltage imbalances and equipment damage. Receptacles are typically rated for either 15 amps or 20 amps. The rating indicates the maximum amount of current that the receptacle can safely handle. Using a receptacle with a lower rating than the circuit's overcurrent protection can lead to overheating and potential failure. For example, a 15 amp receptacle should not be installed on a 20 amp circuit. It is essential to select receptacles with the appropriate rating for the intended application. When working with electrical wiring, it is crucial to follow all safety precautions. This includes energizing the circuit before working on it, using properly insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. Electrical work can be dangerous, and it is essential to take all necessary precautions to prevent injury. Regularly inspecting electrical receptacles and wiring can help identify potential problems before they become serious. Look for signs of damage such as cracks, discoloration, or loose connections. If you notice any problems, have them repaired by a qualified electrician. Proper maintenance can extend the life of electrical equipment and prevent safety hazards. The breakaway tap is a safety feature designed to protect against overheating and potential fire hazards. While it is not intended to function as a fuse, it can provide a degree of protection in certain situations. Understanding the purpose and limitations of the breakaway tab is essential for safe electrical work. In summary, using all 4 screws on a duplex receptacle for feed-through wiring is generally safe, provided that the installation complies with the National Electrical Code, utilizes appropriately rated components, and adheres to established electrical best practices. Proper installation, regular maintenance, and adherence to safety guidelines are crucial for preventing electrical hazards and ensuring the safe and reliable operation of electrical systems. This discussion highlights the importance of adhering to established electrical codes, utilizing appropriately rated components, and implementing proper installation and maintenance practices to ensure the safety and reliability of electrical systems. The breakaway tap on a duplex receptacle is a safety feature designed to protect against overheating and potential fire hazards, but it is not intended to function as a fuse. Understanding the purpose and limitations of the breakaway tap is essential for safe electrical work. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical systems and equipment. It covers various aspects of electrical wiring, including wire sizing, overcurrent protection, grounding, and receptacle installation. Adhering to the NEC is crucial for preventing electrical hazards and ensuring the safety of buildings and occupants. The National Electrical Manufacturers Association, or NEMA, develops standards for electrical products, including receptacles. These standards ensure that electrical products meet minimum safety and performance requirements. Underwriters Laboratories, or UL, is an independent testing laboratory that tests electrical products to ensure that they meet safety standards. UL listing indicates that a product has been tested and found to be safe for its intended use. When selecting electrical receptacles, it is essential to choose products that are NEMA compliant and UL listed. These certifications provide assurance that the products have been tested and meet established safety standards. The rating of a receptacle indicates the maximum amount of current that the receptacle can safely handle. Receptacles are typically rated for either 15 amps or 20 amps. The rating is clearly marked on the receptacle. It is essential to select receptacles with the appropriate rating for the intended application. Using a receptacle with a lower rating than the circuit's overcurrent protection can lead to overheating and potential failure. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and wiring. The size of the overcurrent protection device should be matched to the ampacity of the circuit wiring and the rating of the receptacles. Grounding is a critical safety measure that provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse into energizing the circuit. Grounding helps to prevent electrical shock hazards and protect equipment from damage. The NEC requires that all electrical receptacles be grounded. Multi-wire branch circuits require special attention because they share a common neutral conductor. If the neutral conductor is interrupted, the voltage on the 2 hot legs can become unbalanced, potentially damaging equipment connected to the circuit. The NEC requires that the neutral conductor in a multi-wire branch circuit be pigtailed so that the continuity of the neutral is not interrupted when a receptacle is removed. This requirement is intended to prevent voltage imbalances and equipment damage. Proper installation of electrical receptacles is crucial for ensuring safety and reliability. Receptacles should be installed in accordance with the NEC and the manufacturer's instructions. All connections should be tight and secure to prevent loose connections and overheating. Regular maintenance of electrical receptacles can help identify potential problems before they become serious. Look for signs of damage, such as cracks, discoloration, or loose connections. If you notice any problems, have them repaired by a qualified electrician. Electrical work can be dangerous, and it is essential to follow all safety precautions. This includes de-energizing the circuit before working on it, using properly insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electrical safety is paramount, and it is essential to take all necessary precautions to prevent injury and property damage. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. Firstly, ensure the circuit is energized before working on any electrical components. Secondly, always use properly insulated tools to prevent electric shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, follow the National Electrical Code, or NEC, guidelines for electrical installations. Fifthly, choose NEMA compliant and UL listed electrical receptacles. Sixthly, select receptacles for the appropriate ampacity rating for the intended application. Seventhly, ensure proper grounding of all electrical receptacles. Eighthly, pay special attention to multiwire branch circuits and ensure continuity of the neutral conductor. Ninthly, regularly inspect electrical receptacles for signs of damage or loose connections. And tenthly, if you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical safety should always be the top priority. The proper use of electrical components and adherence to safety standards are essential for preventing electrical hazards and ensuring the safe and reliable operation of electrical systems. The principles discussed here are applicable to various electrical installations, including residential, commercial, and industrial settings. Understanding the function and limitations of electrical components, such as receptacles and overcurrent protection devices, is crucial for safe electrical work. The knowledge and skills of a qualified electrician are invaluable for ensuring the safety and reliability of electrical systems. The National Electrical Code, or NEC, serves as the foundation for safe electrical installations in the United States. It is updated regularly to reflect advancements in technology and address emerging safety concerns. Electrical inspectors enforce the NEC to ensure that electrical installations comply with safety standards. Compliance with the NEC is essential for obtaining building permits and ensuring the safety of buildings and occupants. The Underwriters Laboratories, or UL, plays a vital role in ensuring the safety of electrical products. UL listing provides assurance that a product has been tested and meets established safety standards. Consumers and electricians should look for the UL listing mark when selecting electrical products. The National Electrical Manufacturers Association, or NEMA, develops standards for electrical products, including receptacles, switches, and circuit breakers. NEMA standards promote interoperability and ensure that electrical products meet minimum performance requirements. Compliance with NEMA standards is essential for ensuring the proper functioning of electrical systems. The safe and reliable operation of electrical systems depends on the knowledge, skills, and diligence of qualified electricians. Electricians are responsible for installing, maintaining, and repairing electrical systems in accordance with the NEC and other applicable standards. Choosing a qualified and licensed electrician is crucial for ensuring the safety and reliability of electrical work. Electrical safety is a shared responsibility, and everyone should be aware of the potential hazards associated with electricity. By following safety precautions and working with qualified electricians, we can minimize the risk of electrical accidents and protect ourselves and our communities. The concepts presented here are applicable to various types of electrical receptacles, including standard duplex receptacles, ground fault circuit interrupter, or GFCI, receptacles, and arc fault circuit interrupter, or RSI, receptacles. Each type of receptacle has its own specific features and applications, and it is important to select the appropriate receptacle for the intended use. Ground fault circuit interrupter, or GFCI, receptacles are designed to protect against electrical shock hazards in wet or damp locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupter, or site receptacles are designed to protect against electrical fires caused by arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. Understanding the different types of electrical receptacles and their applications is essential for ensuring electrical safety. The principles discussed here are also relevant to the installation of electrical switches, lighting fixtures, and other electrical devices. Proper installation and maintenance of these devices are crucial for ensuring their safe and reliable operation. Electrical safety is a continuous learning process, and it is important to stay informed about the latest codes, standards, and best practices. The electrical professionals should participate in continuing education courses and training programs to enhance their knowledge and skills. Consumers should also educate themselves about electrical safety and take steps to prevent electrical accidents in their homes and workplaces. Together, we can create a safer electrical environment for everyone. The safety and reliability of electrical systems are paramount, and it is essential to prioritize safety in all electrical work. By following the principles and guidelines outlined here, we can minimize the risk of electrical hazards and ensure the safe and efficient operation of electrical systems for years to come. The knowledge and understanding of electrical safety principles are essential for all individuals who work with or around electricity, including electricians, engineers, contractors, and homeowners. Continuous learning and adherence to safety standards are crucial for preventing electrical accidents and ensuring the safety of our communities. The concepts and guidelines presented here provide a foundation for understanding electrical safety and promoting safe electrical practices in all aspects of our lives.